guys. Here I'm just going to talk a little bit about lab 5 for 275. Lab 5, this lab 5 is about resistance, resistivity, and Ohm's law. Introductory part gives here basically the theory behind the lab. Here it shows how the current and voltage are related. You guys know Ohm's law equation here, and then also this gives the relationship between the resistance, resistivity, length of the conductor, and the cross-sectional area of the conductor. And then this is just basic introduction for a student to show how we represent a resistor, how we represent battery, and so on. So let's jump to the lab. Part 1, it is about resistance and resistivity. Student will need these following things: multimeter, paper clip, and aluminum foil, alligator leads, graphite pencil, paper, ruler. So multimeter, basically you may have to help them to measure the resistance of a resistor. Okay, so this part tells them how to set it up, but I think I'm sure they will have questions regarding how to set up a multimeter so that it can measure resistance correctly. Okay, so here exploration 1, the resistivity of graphite. So for this part, they're going to just use pencil and then try to find the find the resistance of that graphite, not the wooden part, okay, but the graphite, like the pencil part, graphite part. So the core, right? And then using the equation, they are supposed to calculate the resistivity here. So here students record data RLA, and then they calculate resistivity, and then they should include the photo of the experiment, and then their units here. Okay, so units are important, right? So they should be using all SI unit, and then they should find the correct units of resistivity. Exploration 2, this is about finding the resistance of graphite as a function of cross-sectional area. So here this equation R equal to rho L by A, you guys know this equation, right? And then rho L is the same, A is W times T. W here is the width, and then T is the thickness here. Okay, so what they are trying to do here is they are trying to make a graphite sheet basically. So I think there is a picture here, so like this here. See, so this is something students are going to make these, put graphite on the paper. How to do that? Just make a bunch of lines using a pencil on the white sheet of paper, and then they will have so they have this part here, length, and then they also have that part, right? So they are supposed to just make a measurement of this quantity here, and then here in the equation here, so T is the thickness that's unknown. So what they could do to make this is basically start with use a ruler, and then keep making a line by line, and then they can have that graphite sheet with some thickness, right? And then they can measure the R. They should have a constant. L doesn't change here, right? This part L. And then so they measure that T, right, thickness, and then they measure the resistance for that. After that, they will increase that thickness, just again making more lines here, and then make a measurement of the resistance. And then they should be, and then so they will plot a graph of R as a function of 1 by to do so, you graph as R as a function of 1 by W here. Okay, and then using the fitting equation, they are going to calculate what is T from that. Okay, so this is that. But here and then here they just report their graph, linear fit, their calculation, equation of base fit line, estimation of the slope, and uncertainty in the slope. and then calculation of thickness from their theoretical calculation, right? Meaning just using a ruler and just calculate there. So and then also and then compare those with the one they got from the graph. Part 2 is about Ohm's law, ohmic and non. It should be like ohmic devices. Here students are going to measure the resistance R of a different materials. So some of the materials they'll be using is here. So right, multimeter, of course they will need to measure R. So they have a 100 ohm resistor and two other different values. They also have a light bulb, and then they also have a LEDs, and they have a graphite pencil, and they need a battery, right, to connect to have a complete circuit. They can use a breadboard here if they want, but it's not necessary. If you want, you can help them out with that, but it's not necessary. This is here not HM, it should be ohm resistor. Okay. So here they are going to measure the resistance and then find out that some of the materials are actually not ohmic, right? Like ohmic are the one that follows Ohm's law basically, right? So so they will find here basically resistors, right? Of course they are ohmic, light bulb, ohmic, graphite. I think it is ohmic. I haven't done this. I don't know, but I think it should be ohmic. Okay, so this one, I don't know. So you guys probably observe and see what distance report and let me know. And then, of course, lead is not ohmic. It is non-ohmic, so that should be, they will be able to report that. And oh, students are also supposed to calculate. So this part I think I didn't mention here. So okay, so this is new for them on this part here. So this is also, so they have to, they find some voltage at which the LED light is start to emit light, look up the wavelength of the light and calculate energy of the light. Photons emitted by your LEDs using the following equation. So they have to use this energy equal to SC by wavelength. This is really a Planck's equation where H is a constant. It's called Planck's constant. C is the speed of light, and the wavelength is the wavelength associated with that particular color of light emitted by LED. Okay, each student can use this value here, right? 1240 eV nanometer for SC. Okay, if they want, if the wavelength is in nanometer, otherwise they have to do conversion. And then recall the energy of a charge Q crossing a voltage B is what? U equal to QB. So basically find they are going to compare two energies, right? One using this equation and one found using this equation, and then what do they notice about? Okay. All right, so that's about it for this lab. I think it is gonna be, I know it sounds simple to us, but I think for students, I think they will need help, especially like using multimeter, especially like measuring resistance, and then they may ask how to find what value that those color coding means. There is a link here somewhere. I think I forgot to mention. So here, this page is supposed to help. Yeah, so this kind of helps them how to coding. Yep. Okay, so here is a tutorial. Wait, here, this one here. Okay, so the table is here. There used to be, I think, another one we used to have, but all right, I think it's also okay to use this website. Oh, please never mind, that's not the lab I'm talking. So this lab. Okay, guys, so that's about it for this lab. Okay, lab 5. Let me know what they find about the graphite. I think graphite would be ohmic, but I don't know. I haven't done the experiment and I haven't looked at